Hello everyone. Today we are going to derive the relationship between line voltage, line current. Derive the relationship between line voltage, comma, line current, phase voltage, comma, phase current in star connected system. Let me quickly draw the figure. So this is an impedance, so which has inductance and resistance in it. So you have to draw all the three phases. So this is your R phase, and this would be your Y phase, and this would be your B phase. So now I'm going to write what are line currents and phase currents. So let me just write. We'll change the color for the convenience. So this is your line current IR, and this is IY, and this is IB. So these are the line currents. So IR is equals to IY is equals to IB is equals to IL. Now I'm going to write phase currents. So what are phase currents? So current between one line and neutral. So I'm writing IRN. Current is flowing from IR to N. And next it would be IYN. And next it is IBN. So let me just write. So IRN is equals to IYN is equals to IBN. So this is nothing but called phase currents. As I told you, what are phase currents? Current between one line and neutral. Let me quickly write what are voltages. So from R to Y, it would be VRY. And from Y to B, from Y to B. So this is from VYB. And from B to R, from B to R, it would be phase voltage. So I can write VRY is equals to VYB is equals to VBR. That would be our line voltage. Next, I'm going to write phase voltage. So how are we going to write? So I'll just change the color for that. So this is VRN. See, when I say phase, it will have neutral. VRN. So this is VYN, and this is VBN. So these are the three phase voltages. So I'll write VRN is equals to VYN is equals to VBN. That is equals to V phase. So how are we writing this? So actually there's a sequence that needs to be followed: R, Y, and B. So this is the procedure. Let us proceed for further. Now, if you observe, IR and IRN, same current is flowing, and IY and IYN. Can you see the directions of the same direction? So IB and IBN is having same direction. So I'll just write from observation, it is clear that what is clear? IR is equals to IRN, comma, IY is equals to IYN, comma, IB is equals to IBN. So what are IR, IY, and IB? They are nothing but line currents. Let me write IN. And what are IR and IY and IBN? So they are phase currents. So first condition is proved. What is the condition? Line current is equals to phase current. So this is the first condition that I have proved. Now what is the next condition you have to prove? Next condition is you have to prove line voltage. So to prove line voltage, what is line voltage? VL is equals to root 3 times of phase voltage. So for that, what I'll do is I'll take any two phases. Let me quickly redraw this diagram. So let me just draw. Uh, this is R to N, and this is Y to N. So we have quickly redrawn this. So if I see this is an R line, this is Y, and this is N. So what is the voltage from here to here? It would be VRY. And what is the voltage here? So it's VRN. And how will the voltage go? So it's VNY. Now I can write apply Kirchhoff's voltage law. So what is that? VRY can be written as VRN plus VNY. But I told you after R, Y has to come. Right. So here we are getting N. So what I need to do, I need to change these two phases. I'll interchange Y in the place of N and N in the place of Y. So let me just do it quickly. So VNY can be written as minus of VYN. Just substitute it in this equation. So it would be VRY is equals to VRN plus minus of VYN. And I'm done with it. Now I have taken two phases. If you consider these two phases, you'll get one equation. And if you consider these two phases, you'll get another equation. So what are we going to do? We are just going to write similarly. If we consider other two phases, other two phases, what will happen? I can just write this. I can rewrite this equation. Can you see? Like after R, what you'll get? There's a sequence that needs to be followed. R, Y, B, right? So after R, I have Y. So I'll just write V, Y. After Y, you'll get B. V, Y, B is equals to, after R, you'll have V, Y, N plus minus of V, B, N. This is your equation number 2. Let me name this as equation number 1. And we'll finally go with the equation 3. So after Y, you'll have B. So V, B, R is equals to V, B, N plus minus of VRN. This is your equation 3. By using these three equations, now I'm going to draw the phasor diagram. So how are we going to draw? Let me just change the color. So as I said you that these three phases will be 120 degrees apart. So what are they? So this is VRN, this is VYN and VBN. The angle between these three phases would be 120 degrees. So if this is VRN, then the opposite side, obviously it will be minus of VRN. We'll just change it. And this is your V minus of VYN. And this will be minus of VBN. If you see equation number 1, what is VRN and minus of VYN is giving? VRY, no? So we'll just draw. So it's giving us VRY. Let us quickly draw. So this looks like a rhombus. Let me quickly name this. OABC is a rhombus and also OB is perpendicular to AC. Let me write. OABC is a rhombus, comma, OB is perpendicular to AC. And in the rhombus, these are the diagonals are the perpendicular bisectors. I can also write, let me name this as M. I can write OB. OB is equals to OM plus MB. OM plus MB. And I'm also saying they are the perpendicular diagonals are the perpendicular bisectors. So this is not OM, this is OB. Sorry. So just wait. And OB can also be written as OM. So it would be, it's OM plus MB. Okay. This is MB. Let me just change this. So this would be MP. So now I can write OB is equals to OM plus OM. So it would be 2OM. Let me make this as equation 1. Now if you see in right angled triangle OMA, what are the angles in a right angled triangle? One would be 90, another is 60, and another is 30. So total 180 degrees. So 90 plus 90 is giving us 180. So I'll just write in right angled triangle OAM. What is the OAM? Angle OAM is equals to 60 degrees. So angle would be written in between. So what is the angle A here? 60. I just want sine 60. Can you tell, like we know what is sine 60? Sine 60 is equals to opposite to side opposite by hypotenuse. So it will be OM by OA. So what is OM from here? OM would be sine 60 into OA. Sine 60 into OA. Let us just substitute. Substitute equation 2 in equation 1. If you substitute, you'll get OB is equals to 2 into, in the place of OM, I can write sine 60 OA. So what is sine 60? Sine 60 is root 3 by 2. 2 into root 3 by 2 OA. 2 gets cancelled. You'll get OB is equals to root 3 times of OA. And we are done with the equation. So if you see in the phasor diagram, what is OB? OB is nothing but VRY. And what is OA? VRN. So VRY will be equals to root 3 times of VRN. So what is this voltage between two lines? I can say that it's a line voltage. And this is root 3. Voltage between one line and neutral. I can call it as V phase. So I have derived it. So VL is equals to root 3 V phase. So this is very important. Thank you.